Welcome to our discussion on PyMarian, a Python interface for the Marian NMT toolkit. This paper details how PyMarian bridges the gap between Python's ease of use and C+'s speed for neural machine translation, NMT. What are the key advantages of using PyMarian for NMT tasks?
PyMarian offers a compelling combination of Python's rich ecosystem of libraries and tools with the speed of Marian's C+ backend. Researchers and developers can leverage the familiar Python environment while benefiting from Marian's efficient training and inference capabilities. This eliminates the need to switch between languages or convert models, streamlining the workflow.
The paper highlights significant speed improvements, particularly in evaluating machine translation quality using metrics like COMET. Can you elaborate on these performance gains?
PyMarian's PyMarian Evil tool provides a substantial speedup when calculating COMET and BLERT scores. By utilizing Marian's inference engine, it achieves up to a 7.8x speed increase compared to existing implementations, especially in multi-GPU settings. This is due to optimized model loading and efficient processing within the C+ framework.
What are some of the practical applications and integrations showcased in the paper?
PyMarian integrates seamlessly with various Python environments, including Jupyter notebooks, making it easy to experiment with and deploy NMT models interactively. It also provides a straightforward interface for using pre-trained models from resources like OpusMT, and even includes a web app demo for comparing different translation models side by side.
The paper mentions the translator, trainer, and evaluator classes within the PyMarian API. Can you briefly describe their functionalities?
The translator class handles the core translation process, offering various options for beam search, batching, and other optimization techniques. The trainer class facilitates model training, mirroring Marian's training capabilities within the Python environment. Finally, the evaluator class allows for efficient evaluation of translation quality using metrics like COMET and BLERT.
How does PyMarian handle the conversion of existing COMET and BLERT models for use with its evaluator?
PyMarian converts the checkpoint files of popular metrics like COMET and BLERT into a format compatible with Marian. These converted models are then made available through the Hugging Face Model Hub, ensuring easy access and efficient loading within PyMarian Eval.
The paper mentions some limitations. What are some of the key challenges or areas for future improvement?
PyMarian's primary limitation is its focus on Marian-trained models. Users with models trained in other frameworks might face compatibility issues. Expanding support for more evaluation metrics and addressing the resource-intensive nature of some evaluations, especially with larger models, are also areas for future development. The reliance on the availability of COMET Keeley models from Hugging Face, subject to their licensing, is another factor.
How does PyMarian compare to other popular Python-based NMT toolkits like FairSec and the now end-of-life Sockeye?
While FairSec and Sockeye offer comprehensive features, PyMarian distinguishes itself by providing direct access to Marian's speed advantages without requiring model conversion. This makes it a compelling choice for users prioritizing performance while retaining the convenience of the Python ecosystem.
The paper includes benchmarks comparing PyMarian's performance to the original COMET and BLERT implementations. What were the key findings?
The benchmarks demonstrated significant speed improvements across various COMET and BLERT models. PyMarian consistently outperformed the original implementations, achieving speedups ranging from 3.5x to 7.8x on 8 GPUs, with even more dramatic improvements in model loading times. Importantly, the accuracy remained consistent with minimal discrepancies attributable to floating point differences.
The paper also showcases examples of PyMarian's use in Jupyter notebooks and a web application. What are the benefits of these integrations?
The Jupyter Notebook integration allows for interactive experimentation and model development, while the web app demo facilitates easy comparison of different translation models. These examples highlight PyMarian's versatility and ease of integration into various workflows.
What are the key takeaways from this research? What makes PyMarian a valuable contribution to the NMT community?
PyMarian successfully combines the best of both worlds, the ease of use and extensive libraries of Python with the speed and efficiency of Marian's C+ core. This allows researchers and developers to leverage a powerful NMT toolkit without sacrificing performance or convenience. The significant speed improvements in evaluation, along with the seamless integrations, make PyMarian a valuable tool for both research and production environments.
The paper mentions the use of PyBind 11. Could you briefly explain its role in PyMarian?
PyBind 11 is a crucial component of PyMarian, acting as the bridge between the Python and C+ code. It allows for efficient binding of Marian's C+ APIS to Python, enabling seamless interaction between the two languages without significant performance overhead.
The paper emphasizes the importance of maintaining compatibility with the original COMET and BLERT results. How is this ensured?
Careful comparisons were conducted to ensure that PyMarian's results closely matched those of the original implementations. The benchmarks included both single and multi-GPU settings, and the results demonstrated high consistency, with minor discrepancies explained by floating point arithmetic.
Are there any plans for future development or expansion of PyMarian's capabilities?
Future development will likely focus on expanding support for additional evaluation metrics, improving compatibility with models trained using other frameworks, and optimizing performance for even larger models. Community contributions and engagement will be crucial for the long-term success and sustainability of the project.
The paper mentions the use of memory-mapped files. What is the advantage of this approach?
Memory mapped files allow for faster loading of large model files by directly mapping them into the process's address space. This avoids the overhead of copying the entire file into memory, leading to significant performance improvements, especially when dealing with the large checkpoint files used in modern NMT models.
The paper highlights the use of both FP32 full precision and FP16 half precision in the benchmarks. What is the significance of using half precision?
Using FP16, half precision floating point numbers, reduces memory usage and can accelerate computations, especially on GPUs. While it might lead to a slight loss of precision, the trade-off is often worthwhile for the performance gains, particularly when dealing with large models and datasets. The benchmarks in the paper show that the impact on accuracy is minimal.
The paper mentions the OpusMT project. How does PyMarian integrate with this resource?
OpusMT provides a large collection of pre-trained Marian models. PyMarian offers a simple interface to directly load and use these models, making it easy to access and leverage a wide range of language pairs and translation capabilities.
The web app demo uses Flask. Why was Flask chosen for this application?
Flask is a lightweight and flexible Python web framework, making it well-suited for building simple web applications like the PyMarian demo. Its ease of use and minimal dependencies make it a good choice for rapid prototyping and deployment.
The paper discusses the importance of clarity in reporting BLEU scores. How does PyMarian address this issue?
While PyMarian doesn't directly calculate BLEU scores, its integration with other tools like Sacred BLEU allows for seamless incorporation of standardized and reliable evaluation metrics. This ensures that the reported scores are consistent and comparable across different systems and datasets.
The paper mentions the use of keyword arguments in the PyMarian API. What is the benefit of this approach?
Using keyword arguments makes the PyMarian API more Pythonic and user-friendly. It allows users to specify parameters in a more readable and intuitive way, improving code clarity and reducing the risk of errors.
This has been a very informative discussion on PyMarian. Thank you for your insights.